In this video, we're going to go through a couple of classic worded problems that require solving simultaneous equations. And for each one, we're going to need to, with the information given to us, convert that information into equations. Ideally, we're going to get two equations, which we can then solve simultaneously. So let's start with this first one. A farmer has 600 meters of fencing to use and wants to fence off a rectangular field which is 3 times as long as it is wide. What will be the area of the fenced off field? Okay, so the first thing that I'm going to do is I'm going to underline what the question is actually asking me, and that is I want the area of the fenced off field. So at the end, once I've solved my simultaneous equations, I need to make sure I come back to the actual question. I'm going to draw a diagram of this situation. So I've got a rectangular field that's got a width and a length, and I'm told that the length is 3 times as much as the width. So let's translate that into an equation. If the length is 3 times the width, then L equals 3 times W. Now the other bit of information that I have in here is that altogether there's 600 meters of fencing. That means that my perimeter is going to equal 600. So that's 2W, these two, plus 2L, these two, together equal 600 meters. And to find the area of that field, I'm going to need to solve simultaneously. So I've got equation 1 and equation 2. I'll solve them simultaneously to find out the values of L and W, and then I'll be able to use A equals L times W to find the area. So let's do that. I'm going to use the substitution method, and that's because it's by far the easiest one to use here, because I don't actually need to do any work for it. This equation 1 already has a variable isolated. So if L equals 3W, then I'm going to rewrite equation 2, but wherever I see an L, I'm going to swap that with a 3W. So I get 2W plus 2, and then instead of 2 times L, it's going to be 2 times 3W, and that equals 600. I can now solve for W because I've got a linear equation with only one variable. I'm going to start by expanding my brackets here, so I get 2W plus 2 times 3W is 6W, and that equals 600. My next step is to combine my like terms. So I've got a 2W plus 6W, and that gives me 8W equals 600. Therefore, W equals 600 divided by 8, so W equals 75. My last step to solve the simultaneous equations is to substitute that back into one of my equations to solve for L. So if L equals 3W, that was equation 1, that means that L equals 3 times 75, which equals 225. So now I know my values for L and for W. L is 225 meters and W is 75 meters, so the area equals 75 times 225, and that would equal 16,875 meters squared. Great. Let's do one more question. This one's another classic type of question about breaking even. So this is a good question to be familiar with. Let's read it. For an airline to fly a plane from Perth to Sydney involves a fixed cost of $9,000 with an additional cost of $12 per passenger. If the tickets cost $230 each, how many tickets does the airline have to sell in order to break even? So for these break-even type questions, they're all going to follow a pretty similar structure, where the first thing that we want to do is write a formula for the cost. So what will the cost of every flight be to the airline? Well, it's got a fixed cost of $9,000, so that would be for things like, the fuel and for paying the staff, etc., etc. And then on top of that, it's $12 per passenger. So if we label each passenger, if we introduce the variable x for the number of passengers on a flight, then we could say that the cost of each flight is 12x, so $12 per passenger, plus the $9,000 of the fixed cost. If you got a bit lost trying to write this equation, then jump back to watch the video about linear equations and linear relationships, where we went through how to kind of come up with this equation from scenarios like this. Our next step is to write an equation for the amount of money that the airline receives from each flight. So we'll call that R for the revenue. And the revenue for every flight, well, the airline receives $230 for every ticket that's bought. So for every passenger, the airline gets $230. So that would be just 230x. And the question is, how many tickets does the airline have to sell in order to break even? Now, this isn't really a case of simultaneous equations, and we'll see why in a second, but it's kind of included in the topic of simultaneous equations because I've got two equations that I'm going to end up solving for. The reason why it's not really a case of simultaneous equations is because let's focus in on what it means to break even. Breaking even means that you don't lose any money, but you're not making any extra money. So you're making back the exact amount of money that it cost you to run the thing. So breaking even, in terms of the variables we've introduced, to break even means that C equals R. Your cost equals your revenue. The amount of money that you have to spend equals the amount of money that you're receiving. So the way we're going to solve this is by putting these two values, 12x plus 9,000 and 230x, equal to each other. So if C equals R, we're going to substitute each of these for C and R, and we're going to get 12x plus 9,000 equals R, which is 230x. We're going to solve that the way we would solve any linear equation now. I'm going to move my 12x over to that side by minusing 12x from both sides. So I get 9,000 equals 230x minus 12x, which is 218x, and therefore x equals 9,000 divided by 218. And I'm just going to put that into my calculator, and we get that x equals 41.3. But this is an important step. The question was, how many tickets does the airline have to sell? Ordinarily, if I got an answer of 41.3 and I wanted to round that to a whole number, I would round it down to 41. But in this scenario, when we want to break even, if I round down to 41, it means that I'm selling one less ticket. I'm selling 0.3 less of a ticket than I need to break even, which means I'm going to end up losing more money from the costs than I'm gaining from the revenue. So for these break-even questions, we always want to round up. So my final answer then to answer the actual question is that the airline needs to sell 42 tickets.